Semiconductors are the unsung heroes of the digital age. These tiny chips power everything from smartphones and laptops to cars and medical equipment. Imagine a world without these miniature marvels. No internet, no social media, and no instant communication. But what are these magical components? Semiconductors are materials with unique electrical properties. They are not perfect conductors like copper, nor are they perfect insulators like rubber. The invention of the transistor, the fundamental building block of modern electronics, marked a turning point in history. From the first bulky computers to today's sleek smartphones, the journey of semiconductors has been marked by relentless innovation. So, let's embark on a journey to unravel the fascinating world of semiconductors and their profound impact on our lives. The magic of semiconductors lies in their ability to control the flow of electricity. To understand this, we need to delve into the world of atoms and electrons. Imagine an atom as a miniature solar system with a nucleus at the center and electrons orbiting around it. In conductors like copper, electrons flow freely, allowing electricity to pass through easily. Insulators, on the other hand, hold their electrons tightly, restricting the flow of electricity. Semiconductors, as their name suggests, fall somewhere in between. The key to a semiconductor's behavior lies in its ability to switch between conducting and insulating states. This is achieved by introducing impurities, a process called doping, into the semiconductor material. By carefully controlling the type and amount of impurities, engineers can fine-tune the semiconductor's electrical properties. These N-type and P-type semiconductors form the building blocks of transistors and other electronic components. It's hard to imagine a day without encountering semiconductors. They are the invisible force powering our digital lives, embedded in almost every electronic device we use. Take, for instance, the smartphone in your pocket. At the heart of your smartphone lies a system on a chip, a tiny semiconductor marvel that integrates essential components onto a single chip. This remarkable feat of engineering allows your phone to run demanding apps, play high-definition videos, and connect you to the world wirelessly. Beyond smartphones, semiconductors are ubiquitous in our homes. Smart home devices, such as voice assistants, smart thermostats, and security systems, are also powered by semiconductors, enabling seamless connectivity and automation. They have become so ingrained in our lives that we often take their existence for granted. One of the most remarkable aspects of semiconductor technology has been the relentless pace of miniaturization. Over the past few decades, engineers have managed to cram more and more transistors onto a single chip, leading to exponential increases in computing power. This trend was famously predicted by Gordon Moore, co-founder of Intel, in 1965. Moore's law states that the number of transistors on a chip doubles approximately every 2 years. The secret to this miniaturization lies in advancements in photolithography, a process used to etch intricate patterns onto silicon wafers. By using shorter wavelengths of light, engineers can create smaller and more precise features, allowing them to pack more transistors onto a chip. As transistors shrink, they consume less power and operate faster, leading to more efficient and powerful devices. However, this miniaturization trend is approaching fundamental limits as transistors approach the size of atoms. Beyond silicon, exploring new materials for semiconductors. Researchers are actively exploring alternative materials to overcome the limitations of silicon and push the boundaries of electronics. One promising candidate is Gallium Nitride, or GaN, a wide band gap semiconductor with superior electrical properties compared to silicon. Another contender is silicon carbide, or SiC, another wide band gap semiconductor with excellent thermal conductivity. Two-dimensional materials, such as graphene and transition metal dichalcogenides, or TMDs, are also gaining significant attention. These materials hold immense potential for creating next-generation transistors, sensors, and optoelectronic devices. As we demand faster, more powerful, and more energy-efficient devices, these new materials hold the key to unlocking the next generation of electronic marvels. Powering the future. Semiconductors in electric vehicles and renewable energy. The transition to a sustainable future relies heavily on advancements in renewable energy and electric vehicles, or EVs. Semiconductors play a critical role in both these areas, enabling more efficient energy generation, storage, and utilization. Electric vehicles, with their complex power electronics systems, rely heavily on semiconductors. Power electronics devices, such as inverters and converters, use semiconductors to control the flow of electricity between the battery and the motor. Semiconductors are also crucial for developing more efficient solar panels, wind turbines, and energy storage systems. As the demand for electric vehicles and renewable energy continues to grow, so too will the demand for advanced semiconductors. Revolutionizing healthcare. Semiconductors in medical devices and diagnostics. The healthcare industry is undergoing a digital transformation, with semiconductors playing a pivotal role in this revolution. From sophisticated imaging equipment to implantable medical devices, semiconductors are enabling earlier disease detection, more accurate diagnoses, and more effective treatments. Medical imaging techniques, such as MRI and CT scans, rely heavily on semiconductors. Implantable medical devices, such as pacemakers and cochlear implants, also rely on semiconductors. Semiconductors are also enabling the development of personalized medicine, where treatments are tailored to an individual's genetic makeup and lifestyle. Microfluidic chips, also known as lab-on-a-chip devices, use semiconductors to perform complex biochemical analyses on tiny samples. From wearable health trackers to sophisticated surgical robots, semiconductors are poised to play an even greater role in improving patient care. The data explosion, semiconductors, and the rise of artificial intelligence. The world is generating data at an unprecedented rate, thanks to the proliferation of smartphones, sensors, and connected devices. This data explosion is fueling the rise of artificial intelligence, a field that relies heavily on powerful processors and vast amounts of data. Semiconductors are at the heart of this AI revolution, powering the data centers that store and process massive data sets. Graphics processing units, originally designed for rendering graphics in video games, have proven to be highly efficient at handling the complex calculations required for AI algorithms. As AI algorithms become more sophisticated, they will require even more powerful processors and specialized hardware. The development of neuromorphic computing, which aims to mimic the structure and function of the human brain, is a particularly exciting area of research. Challenges and opportunities. Navigating the semiconductor landscape. The semiconductor industry is facing a confluence of challenges and opportunities. The ongoing chip shortage, geopolitical tensions, and the increasing complexity of chip design and manufacturing are creating significant hurdles for the industry. The global chip shortage has highlighted the vulnerability of the global semiconductor supply chain. Governments and industry leaders are now scrambling to bolster domestic chip production and reduce reliance on a handful of key players. Geopolitical tensions, particularly between the United States and China, are also casting a shadow over the semiconductor industry. The increasing complexity of chip design and manufacturing is another major challenge. Despite these challenges, the semiconductor industry is brimming with opportunities. A glimpse into the future. Quantum computing and beyond. Quantum computing, a revolutionary computing paradigm that harnesses the principles of quantum mechanics, holds the potential to solve problems that are intractable for even the most powerful classical computers. Quantum computers use qubits, which can exist in a superposition of states, unlike classical bits that can only be either 0 or 1. This unique property allows quantum computers to perform computations exponentially faster than classical computers for certain types of problems. While quantum computing is still in its infancy, it has the potential to revolutionize fields such as drug discovery, materials science, cryptography, and artificial intelligence. Beyond quantum computing, other futuristic technologies such as spintronics and optical computing are also on the horizon. As we continue to push the boundaries of what's possible, these tiny chips will continue to shape our world in profound ways.